Hello, today's lesson is topic 4.9, parallelograms and trapezoids. We're going to take a look at these quadrilaterals and we're going to find the perimeter and area of them. So when we look at the word quadrilateral, quad means four. So a quadrilateral is a shape that has four sides and four angles. We're looking at two special ones today. Trapezoid is a shape that has one pair of opposite sides, so a very common shape of a trapezoid looks like that. So where the top and the bottom are going to be parallel. And a parallelogram is like a tilted rectangle. So what a parallelogram has is parallel sides, top and bottom, and side, and that's what we mean by congruent. They're parallel and they're congruent, meaning that they are the same. So for example, the top and bottom are the same length and the sides are the same length as each other. So first up, we're going to take a look at perimeter of quadrilaterals. So what we have here is a trapezoid, and I know this because we've got parallel sides on the side here and here, but the top and bottom are not parallel and they're also different lengths. So this is a trapezoid. But because we're asked to find the perimeter, for any shape that is an irregular shape, we can add the side lengths up. The problem is here that they want the shape perimeter in centimeters, but two of our measurements are in millimeters. So on our metric line, millimeters and centimeters are next to one another. So if we want to convert to centimeters, we're going to move our decimal one place over. So 150 millimeters becomes 15 centimeters, and 100 millimeters becomes 10 centimeters. And now that we have all our units the same, we can add up all our sides. So we're going to take 20 plus 10 plus 15 plus 15. So that's going to be 30 plus 30. So our perimeter is going to be 60 centimeters for this trapezoid. So identifying the look of these shapes is really important for future applications. So number 1A, what type of quadrilateral is this? We can see that this has one set of parallel sides, but that the other sides are not parallel. So that's how we know that this is a trapezoid. Whereas for B, we can see that this side and this side, they're parallel and they're the same length. And this side, top, is parallel to the bottom and they're the same length. It's really a tilted rectangle. So this is our parallelogram. For C, they're showing us a right angle in this corner and a right angle in this corner, which means that the lines coming upwards from there are going to be parallel lines. But we can clearly see that the top and bottom are not parallel at all. So this is a trapezoid. So for number 2, if we want to find the perimeter of the parallelogram, we understand that the two matching sides are the same. So 10.3 on the left and right side and 15.2 on the top and bottom. And so we can treat this just like a rectangle, 2 times the length plus 2 times the width. And we can solve this way. So we can take 2 times 15.2 plus 2 times 10.3. And when we calculate that, we end up with 20.6, 30.4 for the first one, plus 20.6 for the second one, so a total of 51 centimeters for this parallelogram. When we're calculating the trapezoid and we want to find the perimeter, we check our units, it's all in centimeters, and we don't need this 12 centimeter height in the middle because the perimeter is the outside measure. So we're going to take 47 plus 20 plus 72 plus 15 centimeters. So the perimeter of this trapezoid is 154 centimeters. Now we'll look at the area of quadrilaterals. There's a number of quadrilaterals that we see: square, rectangle, parallelogram, and trapezoid, and they all have slightly different formulas. and these formulas can be found on your formula sheet. So they become your best friend when calculating the area of these different shapes. Remember that all area is squaring the units, so the answer is always going to be in square feet, square inches, square centimeters, and so on. The area of a parallelogram is nearly identical to the area of a rectangle, because really it's just a rectangle tilted over. But what they have to show us whenever they give us a parallelogram is the height, because the formula for area of a parallelogram is base times height. So the base here is 30, and the height here is 12. So the area is base times height, 30 times 12, and our units here are centimeters, so we're going to be taking 30 times 12 for our centimeters, and when we do that we get 360. And because we're doing centimeters times centimeters, it's 360 square centimeters. So for this parallelogram, we're going to notice its features. And first up, they ask us what the height is. And the height is always projecting from the right angle. So we can see that the height is 10 centimeters. That's very important. The base is where it's coming out, where that right angle is coming out from, the bottom of it. So that's 6 centimeters. So the area is base times height, which is going to be 6 times 10. So the area of this figure is 60 square centimeters. And the perimeter is the same formula as a rectangle, 2 times the length plus 2 times the width. So 2 times 12 plus 2 times 6, which is 24 plus 12. So the perimeter of this figure is going to be 36 centimeters. For a trapezoid, we need to use a different formula in order to calculate the area. So this formula is the height times the bases, and we'll talk about how to identify the bases, divided by 2, and the bases are added together. So notice on this first example, we can see the parallel lines here and here. So we see these parallel lines, and that's the key for us to know which ones are the bases. So 4 centimeters and 6 centimeters are your bases. And it doesn't matter which order you put the bases. And we can see that the height has to be shown to us from the right angle upwards. So our height is 6 centimeters. So once we know this, we can start to figure out the formula. So the area is the height, which is 6, multiplied to the 2 bases added together, 4 plus 6, all divided by 2. So first we're going to do the brackets. 4 plus 6 is 10, so we're going to take 6 times 10, all divided by 2. And now we're going to multiply our numerator. 6 times 10 is 60, divided by 2. 60 divided by 2 is 30. And this is going to be 30 square centimeters, because remember, we multiplied 6 centimeters times 10 centimeters. So we got our square centimeters there. Dividing by 2 is not dividing by centimeters. So our answer is 30 square centimeters. So to calculate the area of this trapezoid, first up we find the height. The height is always projecting upwards from the right angle. So that's going to be 12 centimeters. The bases are the ones that are parallel. Remember, parallel lines never cross. So we're going to have 47 centimeters and 72 centimeters. And it doesn't matter which order you put them in. So the area is going to be 12 times 47 plus 72 divided by 2. Bed mass tells us that we have to add first, so this is going to be 12 times 119 divided by 2, which is going to be 1,428 divided by 2. So the area is going to be 714. And remember, the units are squared centimeters. If you'd like to watch the next short video, I'll be going through a few of the exercise questions.